Quaternions, the numbers of the universe. Well, that title might be true one day, and I'm leading a nascent open science project to see if that's true. But that just begs the question, what's a quaternion? Well, quaternions are numbers with 4 parts, and so you can add them, subtract them, multiply, and divide them. Well, that doesn't sound that extraordinary, but it does sound odd. Can I find something concrete, a concrete example of doing that with 4 numbers? Well, we are all here now. And in 6 hours' time and with various paths, we will all be asleep there then. Now, we don't talk there then, and we don't talk here now. Why is that? Well, I go back a ways, and I blame the Greeks, because they were searching for, permanent perfection. They had axioms, postulates, and proofs. It was a great start, but it imposed kind of limitations by doing that sort of thing. An example is Euclidean lines. I mean, they're perfectly straight. And then you look at nature and you say, everything out there is rough. Everything out there is bent. Fractals are the math of rough, and it was a rough sail to get there. Now, geometry is permanent. You draw that triangle in 3rd grade, it's still there. But yet, everything is temporary, whether it's the sun or my own life. What we need is math that is transient. And so that's why I gravitated to these quaternions, but quaternions have a really bad rep, okay? Though beautifully ingenious, have been an unmixed evil to anyone who has touched them in any way, including Maxwell or myself, for that matter. So there's a lot of people who are against it. And basically, it's a one-trick pony. It's used in the technical field to do 3D rotations, and great for game designers and rocket scientists. But how are we going to visualize these truly strange? No, actually, sorry, this is it. To me, quaternions are really math magic, because if you square one, then you get this core idea in special relativity. If you take a derivative, if you can, you see the fields of electromagnetism. They just show up. So how do we see this thing? Well, analytic geometry is math making a graph. And you get this static graph. That's just y equals x. Nothing too shocking about that. Well, now let's bring it up to the current century. And this is now an animation, a math making a movie. And we have a dynamic image about spacetime. Now, it's a very simple one. It's repetitive addition. Okay, but can we get into some deeper ideas? Well, how about time reversal? Time reversal requires that one remember where you were so you can back out of it. And technically, the time part is a real number. And that leads to the question of what space reversal is like. And you go, oh, that's a mirror reflection. And when the points are gone, there's nothing to reflect. There's nothing on the screen. And technically, that's an imaginary number if you've heard of those things before. And it's all about space. But the amazing thing about these two simple things is that the difference between real and imaginary numbers now makes sense. You don't have to talk about the square root of -1. Those look different because it's memory versus mirrors. But if you now combine time and space reversal, it's like it continues on into the future. And sometimes I just scratch my head and I go, is that really true? I mean, that seems kind of odd, but it is. And when I start animating these equations, there are many things I just don't get yet. This is about sines and cosines, and I love how they create and destroy each other. And they're doing math, but I don't know why they're doing exactly that. Now, most of my time is actually spent looking for a new field theory for gravity. I call it a failure in progress. Okay, and I'm basically searching for a legal variation on Maxwell's equations, but, there are a lot of rules in physics. That's one of the things I figured out. I blog Monday nights at Science 2.0, and I get 1,000 reads there. And the most important thing, though, is that people keep kicking out my chair and pointing out where I'm making mistakes along the way. And I do have a small group working on this particular topic, of course, without any funding. And I track them through YouTube and Quaternions.com, which is at the top of searches, and visualphysics.org, where I have all these animations. And we're doing some jam sessions on Saturdays where we just, hang out and be nerdy and try and find something productive to use with these Quaternions. Oh, yeah, sound was hard to hear. Okay, thank you very much.